Since 1961, over 600 humans have traveled to space. They've walked on the moon. They've lived on space stations. They've become heroes. But that era is ending. And most people have no idea. NASA has been quietly developing something that will make human astronauts obsolete. A new generation of AI-powered robots so advanced, so capable, that by 2030, humans may never need to leave Earth again. What I'm about to reveal has massive implications for the future of space exploration. And it raises a disturbing question. If robots can do everything better, what happens to the dreamers who wanted to touch the stars? Here's the shocking truth that aerospace insiders have been whispering about for years. NASA's budget for humanoid robotics has tripled since 2020. At the same time, their investment in human spaceflight life support systems has quietly plateaued. The agency is making a calculated bet, and that bet is not on humans. Right now, NASA has robots on the International Space Station that can perform tasks no human should ever risk their life for. But what's coming next makes those robots look like children's toys. NASA's next-generation Robonaut 3, combined with Boston Dynamics Atlas technology and SpaceX's Optimus program, represents a leap so profound that former NASA Administrator Jim Bridenstine stated, "The future of deep space exploration will be robotic first, human second, if human at all." By 2030, NASA plans to deploy AI robots that can build lunar bases, mine asteroids, and explore Mars, all without risking a single human life. And the economics make it almost inevitable. Now, what I'm about to share with you isn't just speculation. I've spent weeks researching NASA contracts, Department of Defense robotics programs, and leaked internal documents that paint a picture of a future that's coming faster than anyone realizes. This channel specializes in breaking down the most important stories in space and technology, the ones that mainstream media either ignores or gets completely wrong. We dig into the actual data, the real science, and the implications nobody wants to talk about. If you want to understand what's actually happening with space exploration, not the sanitized press releases, but the real strategic decisions being made right now, then you need to subscribe to this channel. Hit subscribe. Turn on notifications. Because the story I'm about to tell you is just the beginning. The space race is being completely reinvented, and most people will be caught off guard. And stay until the end, because the second twist in this video reveals why this might actually be good news for humanity. It's not what you'd expect. To understand why NASA is pivoting toward robots, you first need to understand just how difficult and expensive it is to keep humans alive in space, because the numbers are absolutely staggering. Sending a single astronaut to the International Space Station costs approximately $55 million per seat on SpaceX's Crew Dragon. But that's just the beginning. Every day an astronaut spends in space requires 1.8 kilograms of food, 2.5 liters of water, 0.84 kilograms of oxygen. The ISS life support system that provides these essentials weighs over 20,000 kilograms and requires constant maintenance. Then there's the biological cost. In microgravity, astronauts lose 1 to 2% of their bone mass per month. Their muscles atrophy. Fluid shifts to their heads, causing vision problems. Their immune systems weaken. And radiation. Outside Earth's protective magnetic field, astronauts are bombarded with cosmic rays and solar radiation. A round trip to Mars would expose astronauts to radiation doses that significantly increase cancer risk. Speaking of Mars, a human mission would take approximately 2 to 3 years round trip. That's 2 to 3 years of food, water, oxygen, medical supplies, psychological support, and constant life support system maintenance. The estimated cost? $500 billion for a single crewed mission. Now, compare that to a robotic mission. Mars rovers Spirit and Opportunity cost about $820 million total. Curiosity cost $2.5 billion. Perseverance was around $2.7 billion. These robots operated for years on Mars without requiring food, water, or bathroom breaks. Opportunity was designed for a 90-day mission. It lasted 15 years. No human mission could achieve that kind of efficiency. And that's when NASA started asking a dangerous question. The question NASA asked was simple. What if we could build robots as capable as astronauts, but without all the biological limitations? The answer has been developing quietly for over 2 decades. In 2000, NASA unveiled Robonaut 1, a humanoid robot designed to work alongside astronauts in space. It had dexterous hands, could use the same tools as humans, and didn't need to sleep, eat, or breathe. Robonaut 2, or R2, launched to the ISS in 2011. It became the first humanoid robot to work in space. R2 could perform routine tasks like flipping switches, cleaning filters, and eventually was intended to perform spacewalks, the most dangerous activity astronauts do. But R2 had limitations. Its AI wasn't sophisticated enough for complex autonomous operations. It needed constant human oversight. It was a proof of concept, not a replacement. That's all changing now, and the acceleration is breathtaking. Watch this. This is Boston Dynamics' Atlas robot. It can run, jump, do backflips, and navigate complex terrain. It can pick up and manipulate objects with near-human dexterity. And it's getting better every single month. Tesla's Optimus robot is designed for mass production. Elon Musk claims it will eventually cost less than $20,000 per unit. Imagine deploying thousands of these on the Moon or Mars instead of risking one human life. Figure AI, Aptronic, Agility Robotics. An entire industry is racing to create humanoid robots that can match and exceed human capabilities. NASA has contracts with nearly all of them. But the real breakthrough isn't the hardware, it's the artificial intelligence. Large language models like GPT-4 and its successors have given robots something they never had before: the ability to reason, to adapt, to solve problems they weren't explicitly programmed for. NASA's Jet Propulsion Laboratory has been testing AI systems that allow robots to make independent decisions during communication delays. When you're on Mars, radio signals take up to 24 minutes each way. You can't have a human operator on Earth controlling every movement. The robots need to think for themselves, and now, for the first time in history, they can. Now, let me reveal NASA's actual roadmap, the plan that's hidden in plain sight across dozens of press releases, budget documents, and strategic planning reports. Because when you piece it all together, the picture is crystal clear. 2024, NASA's Viper rover lands on the Moon's south pole, searching for water ice, completely robotic. No humans required. 2025-2026, Artemis III lands the first humans on the Moon since Apollo. But here's what most people don't know. This mission includes significant robotic systems doing autonomous work before and after the astronauts arrive. 2027-2028. NASA plans to deploy autonomous construction robots to begin building permanent lunar infrastructure. These robots will work 24/7, don't need pressurized habitats, and can operate in areas too dangerous for humans. 2029-2030, the pivotal moment. According to internal NASA strategy documents, this is when autonomous robotic systems become primary for lunar surface operations. Human astronauts shift from operators to supervisors who may not even need to leave lunar orbit. And for Mars? NASA's official position is that robotic missions will always precede human missions by years. Robots will build habitats, extract water, produce fuel, and verify safety before any human ever sets foot on Martian soil. But here's the revelation that changes everything. Internal analysis shows that a fully robotic Mars base could be operational by 2035 for approximately $50 billion. A human Mars base, still looking at $500 billion minimum, with the first crews arriving no earlier than 2040. What would you choose if you were NASA? Spend $50 billion to have a working Mars base by 2035, or spend $500 billion to put humans there 5 years later? Current NASA Administrator Bill Nelson has stated, "We will go to Mars with humans, but we're going to be smart about it. Robots first. Always robots first." Read between the lines. Robots first is becoming robots primarily, and, eventually, it might just become robots only. Now, I know what you're thinking. This sounds depressing. The dream of humans exploring space, replaced by cold machines. But here's the twist that completely changes the story. What if robots aren't replacing human space exploration? What if they're enabling it in ways we never imagined possible? Consider this. While NASA shifts toward robotic exploration for scientific missions, the private sector is investing billions in human spaceflight for tourism, habitation, and eventually colonization. SpaceX's Starship is designed to carry 100 passengers to Mars. Blue Origin is building orbital habitats. Axiom Space is constructing a commercial space station. These aren't scientific missions. They're the beginning of human civilization in space. NASA's robot strategy actually creates a brilliant division of labor. Government agencies use robots for the dangerous scientific exploration, diving into Jupiter's moons, landing on asteroids, probing Venus's hellish atmosphere. Meanwhile, private companies focus on making space accessible and livable for ordinary humans. And here's where economics work in humanity's favor. NASA's investment in robotic technology is driving costs down across the entire industry. The AI systems, the dexterous manipulators, the autonomous navigation, all of this technology eventually becomes available for commercial use. Remember when computers filled entire rooms and cost millions? Now you carry one in your pocket. The same trajectory is happening with robots. The humanoid robots NASA develops today will be mass-produced for space tourism tomorrow. Within 20 years, you might not need to be a highly trained astronaut to live in space. You'll have robot assistants handling the dangerous work, the maintenance, the construction. Human space travelers will be more like passengers than crew. NASA isn't killing the dream of humans in space. They're democratizing it. They're doing the hard, dangerous work with robots, so that eventually anyone can go to space, not just a select few with the right stuff. Let's step back and think about what all of this really means, because we're living through a transition that will define humanity's relationship with the cosmos for centuries. For the first time in human history, we have a choice. We can send our minds into space without sending our bodies. We can explore through robotic avatars, experience alien worlds through VR, and build civilizations on other planets without risking human life. NASA is already experimenting with telepresence systems that let operators on Earth control robots on the Moon in near real time. With improvements in latency and haptic feedback, you might be able to walk on Mars from your living room. Is that the same as actually being there? Philosophically, that's a profound question. If you control a robot body, see through its eyes, feel through its sensors, are you experiencing space or just observing it? But here's what I believe. Both paths forward are valid. Robots will explore the dangerous frontiers, the crushing pressures of Venus, the radiation-blasted surface of Europa, the decade-long journeys to outer planets. Humans will follow in their wake, settling the places robots have made safe. The future isn't humans or robots in space. It's humans and robots, each doing what they do best. And that's a future worth getting excited about. Okay, I need your opinion on this because it's genuinely one of the most important questions facing humanity's future. Let me ask you directly. Question 1. If you could explore Mars through a robot avatar, see everything, touch everything, experience it as closely as technology allows, would that satisfy your desire to go to space? Or does it have to be your physical body? Question 2. Do you think NASA is making the right call by prioritizing robots? Or are they abandoning something essential about human space exploration? I've seen incredibly smart people on both sides of this debate. Some say human presence is overrated. It's the science that matters, and robots do science better. Others say there's something irreplaceable about human footprints on alien worlds. Drop your thoughts in the comments right now. I read every single response, and this is a discussion I genuinely want to have with this community. Your perspective might change how I think about this story. And here's a bonus question for the deep thinkers. If AI robots become truly conscious someday, does their exploration of space count as human exploration? Where do we draw the line? Now, I know some of you are skeptical. You might be thinking, NASA always talks big. They've been promising moon bases since the 1970s. Why should I believe robots will actually replace astronauts by 2030? That's a fair point. Let me address it directly. What's different now is the exponential improvement in AI and robotics. In the 1970s, robots were primitive. They couldn't adapt, couldn't reason, couldn't handle unexpected situations. Today's AI systems are fundamentally different. We're seeing improvements in robotic capability that mirror Moore's law in computing. Every year, robots become significantly more capable, cheaper, and more reliable. That trajectory wasn't possible in previous decades. There's also a massive commercial incentive that didn't exist before. Companies like Tesla, Amazon, and dozens of robotics startups are pouring billions into humanoid robots for Earth-based applications. NASA gets to ride that wave of investment. And honestly, budget constraints make the robot transition almost inevitable. NASA's budget has been essentially flat for decades while costs have risen. They cannot afford the massive expenditures of human deep space exploration using traditional approaches. I'm not saying humans will never go to Mars. I'm saying robots will get there first, do most of the work, and make human missions far safer and cheaper when they eventually happen. That's not speculation. It's NASA's explicit strategy. Could the timeline slip? Absolutely. 2030 might become 2035 or 2040, but the direction is clear. The future of space exploration is robotic, with humans in a supporting role, at least for the dangerous pioneering work. But here's what keeps me up at night thinking about this story. Because NASA's robot revolution might just be the beginning of something much bigger. What happens when these robots become truly intelligent? Not just capable, but conscious? NASA is developing AI systems that can make independent decisions, learn from experience, and adapt to situations their programmers never anticipated. At what point does a robot exploring Mars become more than just a tool? At what point does it become an explorer in its own right? Some scientists believe we're within decades of creating artificial general intelligence, AI that matches or exceeds human cognitive abilities. If those intelligences are embedded in robotic bodies exploring the cosmos, are they the true space explorers of the future? In my next video, I'm going to explore a question that's even more disturbing. What happens when AI robots become so advanced that they don't need human oversight anymore? NASA is already preparing for that scenario, and the implications will challenge everything you think you know about humanity's role in the universe. The robots are coming. The only question is, will they work for us, or will they eventually work alongside us as equals? Let's bring this all together. NASA is systematically shifting toward robotic space exploration for a simple reason. It's safer, cheaper, and increasingly more capable than human missions. By 2030, AI robots will likely perform the majority of dangerous operations on the Moon and will be laying the groundwork for Mars. But this isn't the end of human spaceflight. It's a transformation. Robots will pioneer the dangerous frontiers while private companies make space accessible to ordinary people. The dream isn't dying, it's evolving. If this video made you think differently about the future of space exploration, I need you to do something right now. Hit that like button. It helps more people discover this content. Subscribe to the channel and turn on notifications, because we're tracking this story as it develops. And share this video with someone who cares about space. This is a conversation we should all be having, because the decisions being made right now will determine humanity's cosmic future for generations. I've put 2 related videos on screen right now. One explores how AI is changing everything about space exploration. The other examines what happens when the first private citizens live permanently in space. The stars are waiting, and whether we explore them in person or through our robotic creations, we are going to reach them. The only question is how. Until next time, keep dreaming big. The future is stranger and more wonderful than any of us can imagine, and it's coming faster than you think.